Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem sequence of sequence. So before we proceed further, I would like to mention about my WhatsApp channel. So I've created a WhatsApp channel and I'm posting off-campus opportunities. Either it might be internship or placement related. So please do join the channel, like if you're in case you're looking out for some opportunities in the off campus through off campus. And also planning to post some DSA and CP trucks and also interview preparation tips and some other videos that's going to help you a lot in your interviews and your preparation for your tech industries related. So do join it, do consider joining it, and also please share it with your fellow friends and juniors, because I'm sparing a lot of time towards it, and many of the opportunities that are not known by anyone, I'm posting them there. I'm having direct connections with the companies profiles, and I'm getting able to uh, curate those opportunities. So make sure you join it. The link to the channel is given in the description. Okay, so let us go through this question now. So this is a medium level question and it's the problem of the day on Geeks for Geeks today. So the question says, given two integers m and n, try making a special sequence of numbers seq of length n. Says that. So let seq be the sequence. So sequence of I plus 1 is greater than or equal to 2 times sequence of I. So sequence of I greater than 0 and sequence of I less than or equal to n. So these are the three conditions. Let us understand that in brief through examples later. So your task is to determine total number of such special sequences possible. So your task, like your the output must be the total number of special sequences that can be retrieved. So these are some of the examples given, and the expected time complexity is O of m into n and space is O of 1. But I'm not able to configure a solution with expected auxiliary space as O of 1, because when tell you, like when explain you why I don't think it's not possible. I'll explain you that as well. Okay, so the constraints are m and n goes up to 100. So this is what I'm thinking, that it's not possible. It might be possible, but as far as my knowledge is concerned, I don't think it's really possible to solve this in O of 1. And this topic tags, like don't mind these tags. Okay, so start with this examples now. So this is the example one that has been given, right? So m equal to n, m equal to 10 and n equal to 4. So what can we understand from this? So m equal to 10 in the sense, this is the maximum value. Okay, this is the maximum value. This is the maximum value you can go up with. And 4 is the number of terms in the sequence that you need to make sure you have. Okay, number of terms. So the output is 4. How is that possible? So starting from 1, we have 2 and then 4 and then 8. But why did we come to 2? Because 1, like 2 is actually greater than or equal to 1, right? 2 is actually greater than 1, and also 2 is actually 2 times 1, isn't it? So that is the condition that has been told here. Sequence of I plus 1 must be greater than or equal to 2 times the sequence of I. So whatever the next term that you're trying to put after 1, make sure that is at least greater than or equal to the present term that you have. Okay, so even coming to here, you could have put 3 here, but we did not, because that is not possible. Reason being, so the next term after the 2 must be greater than or equal to the twice of the 2, that is 2 into 2, that's actually equal to 4. That is the reason this is a starting value. And also here as well, we did not put 5, 6, 7. That is, these are not possible, because you need to have the value, next value, that is at least greater than or equal to 2 times the present value, that is 2 times 4, that is actually equal to 8. I hope it made sense, like why did we put 1, 2, 4, 8, right? So now coming to other possibilities as well. Like now what did we list out? 1, 2, 4, 8. Now what is the other possibility? 1, 2, and after 2, like after at least after 4, so we can have even 9, because even 9 is greater than or equal to 2 times 4, right? So we can even have that. And 1, 2, 4, 10 as well, because 10 is also greater than or equal to 2 times 4, right? But we cannot have 1, 2, 4, 11. Why is that so? Because the maximum value we can use is 10, right? So we cannot have this. So that is the reason 1, 2, 4, 11 cannot be counted as a particular solution possible. And now it's done. After 2, we can even go with 5, because even 5 is greater than or equal to 2 times 2, right? This present value. So you can go with 5, and then you can go with 10, isn't it? That is also fine. But can you go with 6? 1, 2, 6. Is that possible? No, because after 6, what is the least term that you can put? 12. But 12 is actually exceeding 10, isn't it? So that is not possible. So if you are going to put 6 here, then the next term should be 12, because you need to make a number of terms as 4. Terms must be there in the sequence that you're making. So after 6 you'll be putting 12, but 12 is not a valid thing, so that is the reason it is also not possible. So this ends up the our combinations. So first combination, second, third and fourth, total 4. That is the reason answer is 4. I hope you people have understood how did we get this 4. Now let us start framing the approach to this question. Okay, so by now you people would have come to a clarity that yes, it is a dynamic programming question, isn't it? Every number has a choice, like whether to pick it or not, so if you're going to pick it, there is going to some you'll be having some end consequence. If you're going to some another pick some other number, you're going to have some other consequence. If you're not going to pick, you can try picking up other numbers. So each and every number has a 2 choice, isn't it? So that's what I've written a tree here. I mean, I've drawn a tree here. So what is our end goal? End goal is basically to make sure to form a sum. Okay, so I'll just zoom it. Yeah, to form a sum of to make sure to use the last term or the greatest term possible as the 10. Okay, not more than that. And the number of terms is actually equal to 4. You cannot use more than 4 terms, and the maximum term that you can maximum sequence term that you can use is only 10. I hope I'm making sense. So you cannot cross 10. Okay, that is your ultimate goal. So how are you going to do it? So there are 2 cases, right? There are 2 cases. If you're considering 10 should be the end of your sequence. Okay, so you're planning to write a sequence like this, and this is your end. So if you're planning to put end as the 10, okay, if you're planning to put end as the 10, so if you're considering it, so what should be the values here? The values can be 5 or 4 or 3 or 2 or 1, isn't it? So these are only the possible values. Can you put 6 here? No, because for 6 the least possible value here it's 12. You cannot put 10, so it's not possible. So for 10 you can, the least possible value, for 10 all the possible values are 1 2 3 4 5. So that is the reason what are we doing is, so if you are planning to put 10 here, okay, if you are planning to put here 10 here, so we can considering 10, that means we are considering 10, so we can go up evaluating like what if we put 5. Okay, so we are fixed, that we are going to put 10 here. Okay, now then we can evaluate on trying to put 5 or 4 or 3. So starting from 5, let us start the examination from 5. Okay, so now coming to 5. Okay, now coming to 5 again, if you are planning to put 5 here, okay, if you are planning to put 5, if you are trying to consider 5, what should be the values that you can put here? 2 1, right? So at this blank, at this particular blank, you can put 1 or 2, isn't it? So 5 is greater than or equal to 2 times 2, 5 is greater than or equal to 2 times 1. That's the reason these 2 values are possible. Can you put 3 here? No, because 2 times 3 is actually equal to 6, so that is not possible, right? So these are the 2 cases. So if you are not planning to put 5, and if you're trying to plan to put 4, so that is the case that we have written here. Okay, so if you are not planning to put 5, that means it is a non-considering case. So NC means non-considering. You're not considering 5, so you can directly consider 4. Okay, again, if you're considering 4, what can be the values that you can put at this point? You can put 2 or 1, right? Or you can put 2 or 1. So you can put both these values, any of these values you can put. And also if you're not trying to consider 4 and you're trying to consider 3 to put here, okay, then also we have a case for that. So NC means you're not considering 4, you're directly considering 3. So I hope you people have understood how did we draw this a tree. So if the tree is basically like this fashion. So every option, okay, starting from 10 4, like 10 is the maximum term that you can use. So if you're trying to consider 10 to be the maximum term, then you can have all these possibilities. You're the left, the left side possibilities you can have. But what if you're not considering 10 to be the last term? If you're considering 9 to be the last term, okay, then you'll be having still 4 more terms. If you can see the second variable, that is also changing, because if I put 10 as a last term, then how many more terms that I need to evaluate? 3, because I've already fixed 1 term at the end. I still need to figure out about the 3 terms. So that's what I'm doing, right? So I hope it's making sense to you people. So basically there are 2 cases for each and every number. So either consider that particular number or do not consider that particular number. Okay, so that is where this particular the tree goes. So if you carefully observe now, okay, if you carefully observe, so the cases I'm considering this case, so I'm considering 10 to be the last term, and also I'm considering 5 to be the a term here. So I'll just write the sequence. So let me erase this. So thing is, like this is how the sequence is. I'm considering this to be 10 and then 5, and then I'll be coming here. I also consider 2. Okay, if I consider 2, then I'll be putting 2 here, and after that, if I consider 2, what would be the next previous term that I can put? Only 1, right? So if I'll even consider this, okay, let us assume I'm even considering this, then I'll be having 1 to 5 10. So once I put 1, so how many terms still more there for me to evaluate? 0 terms, because I've already completed like 4 terms, so I need not worry about any more terms. The requirement is done, so only 0 more terms I need to worry. And also, what is 1 by 2? That is 0. That's the reason we have come to this state. Okay, 0 comma 0, what is that meaning? So I need to figure out the number of sequences possible for putting 0 as a last term. But how many numbers you still have to put? You have already completed the state, right? You have completed the sequence, complete sequence, you have come to an end, so you need not deal with this, right? You need not deal with it. So if you're coming to this particular state, that means you have come to the end. If you're coming to the end, right? This is one of the things that you need to note. And what is the other thing that you can actually notice? So this is done, right? 10 4, like 10 5 2 1. So this is also one of the possibilities, right? 1 to 5 10. So what about 1 to 4 10? If you actually carefully observe, so this is like this. So first one, I'll be putting 10, and then without considering 5. Okay, without considering 5, so I'll be like, I'm not considering 5, but I'll consider 4. Okay, let us assume I'm considering 4. In that case, I'll be putting 4. So if I consider 4, what are the things that I can consider? I'll consider 2, because 4 half is actually 2, so I can consider 2. So I'll be going to 2 here, and again, if I'm coming to 2, again we have come to the same point, right? This is a 2 comma 2, the same thing we have evaluated here. So here 1 by 1, 1 comma 1, and then 0 comma 0. So I'll be again putting here 1 comma 1, right? So the same sequence, 1 to 4 10, 1 to 4 10, the same thing we have. But what about this thing? What about not considering case? Why are we not dealing this particular 1 2? 1 2, why are we not dealing this? So observe it carefully. Your maximum term that you can use is, okay, maximum term that you can use is 1, and they're asking you to frame a sequence of n equal to 2, I mean number of terms equal to 2, number of terms equal to 2. You need to use the maximum sequence, maximum number to be 1, maximum term to be 1, and they're telling that number of terms should be 2. Is that possible? Can you frame a sequence like that? Is that basically possible? Just use your common sense. No, right? So they're asking you to use the maximum value to be 1, and they're telling you to use the number of terms in that particular sequence to be 2. How is that possible? It is not. So whenever you find your maximum value to be less than, okay, maximum value to be less than terms, number of terms, then you put 0. Okay, that means you cannot frame anything. So that's the reason here the answer is 0. Okay, from here there will be no sequences possible. There will be no sequence possible. You cannot form any sequence having 1 comma 2 as the thing, or 1 comma 2 or 2 comma 3 or 2 comma 4, anything where your maximum is less than terms. So that is what, it's pretty clear, right? So this is one of the observation that you need to do. So 1 to 4 10 is also done. Now coming to 1 to 4 9, how do we evaluate 1 to 4 9? So coming to the same tree, okay, so basically here in this particular case, so what did we do actually? So we have taken the 10 to be the last term. What if we are not considering 10 to be the last term? If we are not considering NC, so in that case I'm considering 9 to be the last term. If I'm considering 9 to be the last term, what is the next thing that I can go? 4. And what's the next thing that I can do? Go 2. So once you're coming to 2, then you'll definitely come to 1. So that is the reason what am I writing here? So starting with 9, and then I'm writing 4, and then I'm writing 2, and then 1, right? 1 to 4 9. So this is also done. This is also done. And what about 1 to 4 8? So considering 8 to be the last term. So in that case, do not consider even 9. Okay, do not consider even 9. Consider 8 as the last term. So consider 8, and then consider 4, and then consider 2, and then consider 1. Okay, so the same thing. So it's basically like 1 2 4 8, right? I hope it makes sense for you people. So it's like considering, not considering, considering, not considering. That's it. So we'll even have this 1 to 4 8 as the particular answer. So nowhere else you'll be ending up with this particular state, that is 0 comma 0. Okay, nowhere else you'll be ending with this particular thing. So that is the reason there are no more possible ways, right? I hope I'm pretty clear. You people have understood this thing. So what did we actually come to an understanding that? So the base cases are like, if your I equal to 0, or I would say the number of terms, okay, the number of terms equal to 0, or okay, the maximum term equal to 0, maximum term equal to 0. In both the cases, put the value as 0. Okay, the final output is 0, because if you are asking to make the number, make a sequence such that there are no terms in the sequence, how many sequences can you make? 0 only, right? There are no terms in the sequence, so what sequence can you make? There is nothing, no sequence. So here also in the question you can carefully see sequence of I must be greater than 0. So if they're asking you to make a number of terms to be 0, that means there are no sequence possible, so it is 0, and your max term is also 0. Or in the case of like they're asking you to make a sequence of 5 length and the maximum term that you can use is 0, how can you make? There is nothing, there is no sequence possible, so in that case also it is 0. And what is another case where your max term is less than number of terms? Okay, max term is less than number of terms. In this also written 0. Okay, in this also they are written 0. In this case also it is 0. So they are asking you to, like in this previous case we have seen like the condition where the maximum term that you can use is 1 and number of terms you need to frame is 2 in the sequence. So in that case written 0, because how can you make? Is that possible by using the maximum term as 1 and number of terms to be 2? It is not possible. So that is also that's a point where you will be writing 0. And what's another base case that you can actually identify? So let us assume I'm asking you to make take the maximum term that you can use is 10 and 1. Okay, take that maximum term, the maximum value that you can use is 10 and the number of terms of the sequence is 1. So in that case what are all the possibilities? I can have 1, I can have 2, I can have 3, I can have 4, I have 5, I can have 6. It goes on, right? I can have 10 as well. So maximum value. So how many are possible? Total 10 possibilities, right? Total 10 possibilities. Or if I say you 8 1, so 8 1 in the sense maximum value that you can use is 8 and number of terms in the sequence is 1. So in that case also what are all the possible values? 1 2 3. So individual sequences, right? So how many possibilities will be there? Totally 8 possibilities, right? So this is also another base case. What is that? If your number of terms is actually equal to 1, so I'll just erase this as well. Okay, so if your number of terms is equal to 1, number of terms is equal to 1, in that case that written max term. Okay, written max term. So this is also a particular base case. So these are all the 3 base cases, 1 2 3. And now what is the condition? What is the condition that you're going to write? So I'll even write this. So what is the formula that you're going to write? So if for a particular value, for a particular evaluating, so let us assume I'm evaluating for 10 4. What are the values 10 4 is depending upon? If I'm considering 10 to be the endpoint, then I'll be evaluating the value of 5 3. If I'm not considering it, then I'll be evaluating the value of 9 4, because I'm not considering this to be an endpoint. So still I have 4 terms to be evaluated. So 4 and the end term will be 9, right? So the same thing that we have even written in the code. So dp of ij basically depends upon dp of I by 2 j minus 1 plus dp of I minus 1 j, right? I minus 1 j. This is what I have written. So dp of I depends upon dp of I by 2 j minus 1 plus dp of I minus 1 j. So whatever the thing you take, let us assume you are taking 4 comma 3. On what two values it is depending? It is depending upon 2 comma 2, that is I by 2 comma j minus 1, and I minus 1 comma j, that is 3 comma 3, right? So it's pretty evident, right? So whatever the state that you take, it depends upon two values, two children, right? That is what we have written here. That is the same formula that we have clearly written in the dp state. So the brute forces, you can just use the recursion and do it. That is also completely fine, because the MNN goes only up to 100. Sorry, the brute force, it is basically 2 power 100, right? 2 power 100 it goes. So I don't think it will really work 2 power 100. So and another thing is that is the reason like this is brute force. That is the reason we need to use the DP, iterative DP. So where we can use a bottom up approach to solve this particular problem. DP of ij depends upon 2 states. Now why did I say that it cannot be solved in O of 1? The reason being, we would have solved this type of problems previously, right? Like dp of ij, it depends upon dp of I minus 1 j plus dp of j or I j minus 1. So we would have solved many problems like this, isn't it? Where your present state depends upon previous state only. Okay, previous state and the like before state, I mean to the left and to the top, right? This is how some of the DP problems are. But in this case, it only depends upon the previous row, right? It only depends on the previous row and the present row. It only previous row and present row, previous and current. That's the reason we were able to solve this. But right now, is it depending upon like that? It is depending upon I by 2. It is depending upon upon I by 2. Every number has different I by 2. Every number has different I by 2. 1 has different I by 2. 2 has different I by 2. 7 has different I by 2. 10 has different I by 2. So we need to store the values, right? If I'm evaluating for 10, what are all the rows that I'm depending upon? I by 2, that is 5, and I minus 1, that is actually 9. If I'm working on 9, what are the values that I'm depending upon? 9 by 2, that is actually 4, and 9 minus 1, that is actually equal to 8. So if I'm working on 8, what are the values that I'm going to depend upon? 8 by 2, that is actually equal to 4. 8 minus 1, that is actually equal to 1. So for each and every value, you see each and every row, there are some certain values that are there. So 5 and 9 for 10, 4 and 8 for 9, 4 and 7 for 8. So I think it's not practically possible, like as far as my knowledge is concerned, that we can just solve it in O of 1 by taking two vectors outside and another vector inside. I don't think it really works, because I tried, but I'm not able to figure out a logic, because for each and every a row, there is a different dependencies, right? It's just depending upon its previous row. It's also depending upon I by 2 row, right? So we also need to store this. So instead of complicating ourselves, it's better you stick to O of m into n, because the constraints are pretty clear, I mean, just up to 100. So it's pretty minimal, so it's better to confine to O of m into n as the space complexity. And time complexity, anyways, it goes up to O of m into n, that's for sure. So this is the overall picture of this particular problem. I hope you people have understood. So whatever we have come to a conclusion, that is what we have written in the code, right? Whatever we have seen, that is clearly evident in the tree diagram. The same thing I have also put in the code. This is the formula, this is the formula, this is the formula, right? This is how it's depending upon, and these are the base cases. These are the base cases. So these are the base cases. So there are three base cases. That is what I've written. So if we just move up to the compiler, you can see the same thing. First I've taken a 2D vector, right? M plus 1, n plus 1, and I goes up to m plus 1 and j goes up to n plus 1. So if I equal to 0, that means the maximum term equal to 0. So this is like maximum term, right? So maximum term, I'll even write this here, maximum term. Okay. Fine. Okay. Yeah, maximum term. This is maximum term, or this is like number of terms, right? Number of terms. So either this might be 0, or if this is 0, or I less than j, like your maximum term is less than number of terms, in that case your DP state would be giving you 0. Else if j equal to 1, that means number of possibilities would be I, because if j means number of terms, like number of terms in the sequence is 1. So whatever the maximum term possible, that many number of sequences that you can form. Else this is the formula, right? This is the formula. So what is the formula? DP of ij equal to, so I'll just write this formula, this is the formula. So dp of ij depends upon two states, I minus 1 j plus I by 2 comma I by 2 j minus 1, right? So these are two states it's depending upon. And finally return dp of m of n. So what is m? M is actually 10 and n equal to 4 in the example that we have taken. So what does that actually dp state denote? The number of sequences that can be formed by putting 10 as the maximum term and n is equal to number of 4, like number 4, using 4 terms as the number of terms in the sequence, right? So that is the dp state is defining. So that is pretty evident from this itself. I need not explicitly mention. I've already worked upon that thing only. So 10 comma 4 depends on 5 comma 3 and comma 4. Consider or not consider, only two cases. So that's how we have evaluated the whole thing. So I hope there's no confusion. I'll even submit this code for your reference. Okay, yeah, work fine. So I hope you people have understood. If there are any doubts, please feel free to comment in the comment section. Also, for your reference, course in C++, Java, Python are there in the description. Please go through them. And thank you for watching, guys. Stay tuned.